Hey, what's up guys? This is Porter Roskelley for Dr. Delacourt's Physics 106 class, and this is my video on resistors in series and in parallel. Okay, to start off, we're just going to start talking about what is resistance, get a little bit of a review. So, say we have a current, right? A current I. If you think about voltage is kind of the measure of how much voltage is needed to push that current, right? So voltage is kind of the thing that pushes current, and you can kind of think of resistance as the thing that pushes against the current, right? If you think about it in kind of in terms of like friction, okay, so you've got like a box that's on the ground, and that box is your current I. Your voltage would be like the force that's pushing against that current, and resistance can kind of be thought of as like friction, right? Resistance is that force being pushed back. And so really what resistance is a measure of the voltage that is needed to drive a specific current, how much voltage you need to push that current, okay? If we think about it in terms of Ohm's law, right, you've got voltage is equal to current times resistance. If you flip that around, you can do resistance is equal to voltage over current, okay? Or resistance is equal to the voltage needed per a specific current. So if we use numbers, let's just model this. If you've got 1 ohm, that's going to equal 1 volt over 1 amp. So ohm is the unit for resistance and amp is the unit for current. So this means that if you've got 1 ohm, that means that you've got 1 volt needed to push 1 amp. Let's say that you double the resistance in a circuit, okay? You've got 2 ohms now, and if you want to keep the same current, how many volts do you need? If you want to push 1 amp of current through that circuit with 2 ohms of resistance, you're going to need 2 volts. So that's kind of the relationship of resistance. Within a circuit, resistance is going to be modeled, if you've got this circuit diagram here, it's going to be modeled as a jagged line like that. That's going to tell you that as the circuit goes through, it's going to hit that resistor and need a certain voltage to push the current through. I also kind of like to think of it in terms of like a water tube, right? If your circuit is kind of like a big tube of water pushing water through, a resistor can kind of be thought of as a place where the tube gets smaller. So as you've got water going through, only a certain amount can actually get through, okay? And you need a certain voltage to push that current through that smaller tube, okay? So only a certain amount can get through, okay? Okay, the next thing we're going to talk about is resistors in series. So now that we know what a resistor is, what does it mean to have resistors in series? Okay, having a resistor in series means that you've got multiple resistors in a circuit, and the current has to run through all of them, okay? There's no option. It's as it comes through this circuit, you see it goes through R1, and then it has to go through R2 and R3 to make it through to finish the circuit. I kind of think about it again with the water diagram, as you've got this big tube, right? And then as it goes through current 1, it's resisted down a little bit, and then through number 2, it's resisted down a little bit more, and through resistor 3, it's resisted down even further. And so by the time it gets here, that current is very small. So how do you find the total resistance in a circuit when resistors are in series? It's actually a pretty simple equation. You just use this equation up here. The R total resistance is equal to the resistance of R1 plus R2 plus R3 plus however many resistors you have within that series. And when you add up those resistances, you find that total resistance. So let's say we have a 12 volt battery in a circuit, and R1 we'll say is equal to 2 ohms, R2 is equal to 4 ohms, and R3 is equal to 8 ohms, okay, just to practice this. So using that equation, R total is equal to simple 2 plus 4 plus 8, and that's going to equal 14 ohms, okay? So this is the total resistance in this circuit. And what we can do with that is now we can solve for the total current in the circuit. So as you can see here, if you've got a current this big at the very end, it's going to be the same current throughout. If you've only got, let's say, 1 gallon of water going through, you can't have more than 1 gallon of water coming through the other ones as well. So this current is going to be the same throughout. And the way that we're going to solve for that is, again, using Ohm's law. So we'll just do current is equal to the voltage divided by R total. So you're going to say equal 12 divided by 14. So that total current is equal to 0.86 amps, okay? So now what we can do with that, now that we've solved for the total current running through the whole circuit, we can solve for the individual voltage drops, or how much voltage is needed to push the current through each individual resistor. And again, we're going to use Ohm's law, V equals IR. And so the I we're going to use is this current that we know is running through each one, and the R is the individual resistance of the resistor. Okay, so for V1, we'll use 0.86 times R1, which equals 2. And that equals 1.7 volts. We'll do the same thing for V2, 0.86 times 4, which equals 3.4 volts. And then voltage 3 is equal to 0.86 times 8, which equals 6.9 volts, okay? So this is how much voltage is needed to push through each individual resistor. It's the same current that this voltage is pushing through different resistors. And so what you can kind of do is you can kind of think of this as a single circuit with one resistor that is 14 ohms. It's a kind of a simpler way to model this. And if this is still a 12 volt battery, the cool thing is if you add these up, it actually equals 12 volts. Okay, and that's important because it's saying that it's different amounts of that single 12 volt battery are required to push this through. And then if you do, and this equation up here, you can see that with that current, that's how many volts it takes to push through a 14 ohm resistor, okay? So that's kind of the importance of resistors in series, is that they add up together to create a really, in essence, one really big resistor. Okay, the next thing we're going to talk about is resistors in parallel. Okay, so this is kind of a different idea than resistors in series. In series, they're right in a row, right? It has that current has to go through all of them. Resistors in parallel is like saying that your current has options. It kind of has different ways that it could go. It could go, as it goes through, it can either go through resistor 1, resistor 2, or resistor 3. So they're kind of lined up and all individually wired to that battery. I kind of think of this again in the terms of water, that water tube, right? You've got a big water tube that's then resisted down, but it's got multiple options to go through. It doesn't just have one resistor to go through. And so what this means is that when it comes to the value of the total resistance, the value of your total resistance has to be lower than the individual values of each of these resistors. So again, let's give some values. We'll say 2, 4, and 8 again. Okay, that means that the total resistance has to be less than 2. It has to be less than the smallest resistor. And the value, the way that this kind of works out with the math is, this is the equation that we're going to use. So 1 over the R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over however many resistors you have in parallel, okay? So let's just do that real quick. The way that that's going to come out is we're just going to do 1 over 2 plus 1 over 4 plus 1 over 8. And that's going to give us 0.875, okay? But that's 1 over the R total. So what we do next is 1 over 0.875, which equals 1.14 ohms. And that's our R total, okay? So this is the total resistance of these resistors in parallel. And we'll kind of use that a little bit later to talk about the current, but the current running through each of these resistors is going to be different because there's the same voltage going through. So because each of these are wired to the battery, they're feeling the same voltage, okay? And so that means the current is going to be different through each one, and that's what we're going to solve for here. Again, using Ohm's law, it's a really good equation to use when we're talking about these resistors, okay? So what is the current passing through resistor 1? Well, I equals, we know, VR. So we're going to use, again, a 12 volt battery. So we'll do V over R. I equals V over R, 12 divided by the value of R1, which is 2. 12 divided by 4, and 12 divided by 8, okay? And these values come out to 6 amps, 3 amps, and 1.5 amps. Okay, so this is the current running through each one. And then what's important is you can add them together to get your total current, which in this case is 10.5 amps. So this is the current, kind of, you could say right here. There's a current of 10.5 amps. And you could think about it in terms of like the water. You've got 10.5 gallons running through right here. And then as it splits up, you've got 6 gallons going here, 3 going there, and 1.5 going there. And then they come back together to be 10.5 gallons again, or 10.5 amps, okay? And again, just like in series, you can draw this as a single resistor, okay? You got a 12-volt battery here, and this is going to be 1.14 ohms, okay? And if you were to solve for the voltage running through here, you would do I equals V over R, or 12 divided by 1.14, which equals 10.5 amps, just like up there. So it's the same thing. So that's kind of how you can model resistors in parallel, is they just come together to be one single resistor that is a lower value than any single resistor. Okay. The next, so just to finish up real quick, we're going to kind of do a model of what it looks like to have resistors in series and in parallel. So all together, let's say, so this is a one that I drew, right? So you've got a 12-volt battery here, and you've got resistors in parallel here, a value of 2 ohms and 3 ohms, and then another one of 4, 5, and 6 ohms, and then one of 3 ohms by itself. So to handle this equation, what you're going to do is you're going to first put the ones in parallel together, and then treat them as 3 resistors in series. So we'll call this one R1, R2, and R3, okay? So to solve for R1, first we'll just do that by itself. 1 over 2 plus 1 over 3, which is equal to 0.83. You take 1 over that, and that equals 1.2 ohms, okay? So this whole value together equals 1.2 ohms. For R2, we'll do 1 over 4 plus 1 over 5 plus 1 over 6, which equals 0.616. Take 1 over that, and that's going to give you a value of 1.62 ohms. Sorry, my ohms are terrible when I draw them. And the value of R3, we can already see, is 3 ohms, okay? So then we'll just treat this as 3 resistors in series, okay? And how do you solve for that? You just do R1 plus R2 plus R3. So you're going to do 1.2 plus 1.62 plus 3 equals 5.82 ohms, okay? So that's our total resistance running through this circuit. So again, just like we've done before, you can draw this as a single circuit of 5.82 ohms with a 12-volt battery, okay? And the reason that this is important is because then you can solve for the total circuit running through, just like we've done before, using simple I equals V over R. So your total current is equal to 12 volts divided by 5.82 ohms, which is equal to 2.06 amps. I believe that math is right. So this is the total current running through this entire circuit. So that's how you'd solve a problem given to you if they gave you a circuit with resistors in series and in parallel, to be able to find total voltage, or total ohms, total amps, whatever they ask you to do. This is kind of how you deal with that. I hope you enjoyed the video today. I hope you learned something. I hope you have a great day.